Welcome to the Stormsurf video surf forecast for the week starting Sunday, April 12th. Looking at significant wave heights for the North Pacific Ocean, we see an area of 28-foot seas developing west of the dateline. This, a new storm forecast to track across the dateline and into the Gulf of Alaska, giving us some hope for yet one last swell before winter is fully over. Otherwise, a little bit of energy in the western Gulf of no real interest, and otherwise a placid pattern in the north. First up, we'll take a look at jet stream level winds. These winds, up about 30,000 feet, help support the formation of storms, and when those storms do form, help direct their track. Currently, a little bit of a trough is trying to form here, east of the Kuril Islands, with 140 knot winds in its center, maybe a little bit stronger, starting to dig out a little something here. This is supporting low pressure development down at the surface. Also notice another little bit of a trough, that is a dip in the jet stream. This helps support counterclockwise rotation in the upper atmosphere and down at the surface alike. Anyway, this little trough is supporting low pressure, but nothing more. Also notice the bigger picture here, a split jet stream flow. That is, most of the energy is tracking across the north, but a little bit is going across the south, and this configuration supports high pressure down at the surface. Let's put this into motion. As we roll out here, this trough continues into Monday, and then sort of weakens, not a whole lot of wind energy in it. Maybe 140 knot winds, but that's nothing particularly interesting. And then it sort of gets beefed up again on Tuesday night. Another area of, 160, almost 170 knot winds develops, pushing 190 knots into Wednesday morning, feeding yet more trough activity in the western Gulf, and then it all sort of falls apart. Things get weak. The jet splits over Asia, and just a very kind of fragmented pattern by Friday. And then another little trough here by Saturday. But again, wind energy real weak. Not a whole lot going on, but do notice here that the jet, no matter how weird its configuration is, it's actually kind of pulled together a little bit, at least in this image, but not super organized. And then we're out to Monday a week, split flow over the west, kind of just fragmented and a mess in general. So the biggest activity looks to be the trough currently over the dateline. Next, we'll take a look at surface level pressure and surface level winds. Currently, we see a small storm, 50 knot winds, actually hidden underneath the tag here. Pressure down, let's say roughly about 972 millibars. Not a large storm, but it is creating 50 knot winds aimed somewhat at Hawaii and, of course, at the U.S. West Coast. And then weak low pressure in the northern Gulf, not doing a whole lot. Put this into motion. Here we go into Sunday night, early Monday morning. Little peak here of 55 knot winds, but mainly 50 knot winds, pushing basically flat to the east. This would suggest sideband energy for Hawaii, more direct energy for the U.S. West Coast. Roll this out. That continues. Still 50 knot winds through midday Monday. And then by Monday night, the system is racing into the western Gulf. Winds down to 45 knots. High pressure building along the U.S. West Coast. And we'll roll this out a little bit further. That gale continues it's now down to gale status, working its way into the northern Gulf by Tuesday night. And notice here, strong high pressure, 1032 millibars starting to build on the dateline. So, swell seems likely, assuming this system here does what it's supposed to. Also notice here, high pressure pushing into the U.S. West Coast, building strong north winds along the coast, this on Wednesday. Roll this out, and then as another low pressure system tries to organize, but just doesn't do a whole lot. We saw on the jet stream level model, strong winds feeding this trough, but for whatever reason, it just doesn't get that organized. 35 knot winds, but notice this, they're southwest winds mainly pushing up into Alaska. Not a whole lot at the U.S. West Coast, certainly nothing at Hawaii. A little bit of back door fetch here now towards Hawaii on Friday night, if you believe the models. 35 knot winds. We'll check that out when we get to the significant wave height charts. Anyway, that sort of fizzles out. High pressure, again, takes over the dateline region, and a week out, things go back into a dormant state. So here we go. Significant wave heights for the North Pacific Ocean. Here's our storm. Small area, 28-foot seas. Aimed roughly down the 315 degree track to Hawaii, and on the 298-degree track to Northern California, relative to Southern California, about 302 degrees. Anyway, we'll put this into motion. This system builds 41-foot seas by, here we go, 41-foot seas by Monday morning. Relative to Hawaii, again, that's moving more now towards the about 330-degree track. And relative to Northern California, right up the 296-degree track, and Southern California about the 301-degree track. We'll roll it out a little bit further. The system peaks out right there at a Monday night, 44-foot seas relative to Hawaii. What is that? Kind of hard to see there. About 338-degree track, roughly. But notice the swell vector is almost perpendicular to the Great Circle track, so not a whole lot of energy pushing down into the islands when this system peaks out. But relative to Northern California, right on the 296-degree track, that's a good angle. And relative to Southern California, again on the 301-degree track. The system continues to the east and starts fading by Tuesday morning down to 40-foot seas and moving north. It's into about the 298-degree track to Northern California and about the 303-degree track to Southern California, and then quickly fades and is out of the picture. Another system forecast behind generates, 22-foot seas, but this is what we saw before. Most energy pushing up in this direction, certainly not at Hawaii at all. Relative to Northern California, maybe some sideband swell, in about the 300-degree range or so, and much further north for Southern California. Anyway, and then another little fetch, we saw that before, so relative to Hawaii, this is the best shot there, 347 to 350 degrees, and again, kind of aimed 45 degrees or so off the Great Circle track. Still a little bit of energy is possible if this thing forms as forecast. Then it too kind of fades out, and that's the end of it. We'll also take a quick look at the southern hemisphere, specifically this area right here. Little gale developed on Saturday, peaked out about 28-foot seas, aimed up into the Tasman Sea, almost 30-foot seas there, just barely, let's say 29-foot seas relative to Fiji. Nice and clear there for Hawaii. Very well shadowed. It's going to go through the cheese grater here for sure. Probably not a whole lot of energy for the islands, especially considering it's only got barely 30-foot seas to start with. But it does push pretty well to the north. Good swell likely to result for Fiji. And then another tiny little system here. Actually, we'll go back. That starts on Monday morning. Maybe getting 32-foot seas relative to Hawaii. I mean, this is a tiny, tiny little system. That's about the 200-degree track, but aimed north. So a little background swell likely for Hawaii. No interference from any islands or anything, so it should do much better, at least for the islands. The mainland, maybe not so much. And then it sort of fades, but gets a little bit better footprint here, 26, 28-foot seas, maybe good for more 14-second period swell relative to Hawaii if this does as expected, and that's again on about the 200 to about the 195-degree track or so, and pushing well to the north. And then that fades out, and then really nothing happens at all after that. No real good clean energy in the California or Hawaii swell windows. Let's take a look at long-term projections. First up, we'll take a look at the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Currently, about a neutral pattern. That is 2.0. Not really negative, not really positive. Long runs of negative numbers represent the active phase of the MJO, or perhaps the formation of El Nino. Long runs of positive numbers represent the inactive phase of the MJO and or La Nina. Currently, neutral pattern, at least by the daily numbers. Looking at the 30-day running average, minus 8.68, suggestive of the active phase of the MJO, which peaked out somewhere right in here, early part of April. Good long run of negative numbers, but now it's starting to lose some ground. And the 90-day running average, minus 7.04. This has been toggling between minus 6 and minus 8 since October. We are in some sort of a weak flavor of El Nino, but very weak, what we're calling a Modoki El Nino. Probably nothing more than that, and it hasn't had much effect, if any, on this winter's storm pattern. Next up, let's take a look at wind anomalies, differences in wind direction and wind speed for this time of year for this area of the ocean. Australia here, Philippines here. What we're looking for is westerly anomalies. Westerly anomalies suggest the active phase of the MJO. Prolonged bouts of westerly anomalies suggest the formation of El Nino. Currently, very weak westerly anomalies in play to the dateline. Then another little patch of westerly anomalies north of the dateline. It is westerly anomalies that push warm water to depth and create Kelvin waves. Kelvin waves are the hallmark of El Nino. Currently, we don't see any solid support for Kelvin wave development, but certainly we do not see strong trades. We don't see anything dampening or suggestive of cool water migration to the east, so that's a good sign. Looking off now further to the east, we see again weak westerly anomalies making it to a point south of Hawaii, and then things go neutral. Pretty normal for this time of year in this location. A week out, again, a continuation of very weak westerly anomalies. Nothing strong, nothing really supportive for Kelvin wave development, but still, not bad. We'll take it. Then that dying on the dateline, and then we continue east from the dateline. Again, basically a neutral pattern, just kind of nothing, basically a normal pattern. This is the historical view of westerly anomalies. Westerly anomalies are reds and blues in this image. And again, the date line is here. The far west Pacific is roughly over here. The far east Pacific is here. We see back in March the tail end of what was a very strong westerly wind burst. But now, slowly, westerly winds have been dying. And here's the forecast. Another little patch of weak westerly winds forecast a week out, but nothing particularly strong. But the good news is no solid signs of blues, which would be easterly anomalies. So we're still in a pretty good place. The outgoing long-wave radiation forecast, that is the amount of sunlight reflected off the ocean surface. Oranges and yellows suggest more sunlight reflection, the inactive phase of the MJO, and high pressure and or easterly anomalies. Blues suggest less sunlight reflectivity, more cloud cover, and the active phase of the MJO. Currently, per the statistic model, a weak inactive phase slowly forecast to fade out, with a weak active phase working its way into the West Pacific and presumably continuing along the equator to the east. Now here's the interesting part. The dynamic model says weak inactive phase, and it just is supposed to stay there for the next 15 days. So either model, though, is basically saying a very weak pattern, no strong MJO activity, so that would mean no strong westerly wind bursts, no strong support for storm development. Interesting point here. We have a solid storm in the North Pacific, but we are in effect in the inactive phase of the MJO. So what that means is you can still have decent storms with or without the presence of the MJO, but when the MJO is in the active state, it tends to support more strongly the formation of storms. And when you see strong storm cycles during winter months, almost always it's associated with the active phase of the MJO. But now we're moving into the spring season. All that influence is fading out. Getting any storm activity at all is a plus. We'll take it. The long-term 40-day upper-level model. Green suggests areas of supportive of precipitation and theoretically the active phase of the MJO. And there has been this sort of pattern of wetness that's been hanging, lingering in the charts over the West Pacific. Now it's starting to work its way east, expected to fade out here by the end of the month. And notice the inactive phase, this is areas not supportive of precipitation, and presumably the inactive phase of the MJO is to take over per this model. This is a dynamic model, much like the other model we saw earlier, so it's no wonder that they are in correlation with one another. Anyway, the inactive phase is to work its way across the equatorial Pacific into about middle of May, and then supposedly a weak active phase develops again. But this time of year, the MJO doesn't have a whole lot of influence one way or the other, so it's not surprising that we don't see a whole lot going on here. Next up, surface level temperature anomalies, differences from normal for this time of year. Clearly, a warm pattern along the South American coast, suggestive of weak El Nino, with a little pocket of extra warm water here near the Galapagos, but still, this is not a strong El Nino signature by any means. And a weak, warm water over the equator, but notice this cool pocket of cool water here, just 3 degrees south of the equator. This is the same sort of situation that developed last year with cool water in this area, but this warming is occurring much earlier this year than normal and is already well entrenched along the U.S. West Coast, though one would never know it by being in Northern California this past couple of days. Strong north winds have caused strong upwelling. Water temperatures are down indeed, but in general still warmer than normal for this time of year. And warm water over Hawaii. So all the conditions are ripe for development of El Nino. We just need to have it happen. And so far, there's nothing atmospherically that suggests it's really any different than any other time. But this warm water here should do well for tropical development in the coming months if it holds in place. Here's yet another view. This one hypes it up a little bit more, makes it look warmer than it really is. But it is this area here that we're interested in, and we can zoom in. So I'll do a little time lapse here. Here's the temperatures along the Peruvian coast, the 1st of March. The 7th of March, even cooler. The 14th of March, starting to warm up a little bit. And then the 21st of March, getting much warmer, suggestive that a Kelvin wave of some sort was impacting the area. And building even more into the 28th. Nice warm temperatures along the coast here. But then we get into the 5th of April, and the temperatures have backed off along the coast, become more concentrated up here, and then holding about the same currently. The point being, there was a big warm-up. It seems to be losing a little bit of traction now, but still is respectable, but not over the top. Certainly nothing that would suggest a major El Nino is in development. Looking in the main Nino area, Nino 3.4, that is roughly from about 170 west, that'd be here, to about 120 west. This is the main area you look for warm temperatures, not along the Peruvian coast, to confirm the presence of El Nino. Now here, these are absolute temperatures, and this from April 9th. There's been some, appears to be some problems with the TAO buoy site not updating its data. We're sure the buoys are fine. It's just probably a site issue. Anyway, you see temperatures, but it's the difference in temperatures that are of the most interest. And here we see only 0.5 degree anomalies along the equator with a little pocket here of 1 to 1.5 degree anomalies. Nothing suggestive of what we'd call a strong El Nino or even a moderate El Nino. Very weak indeed. But still, also notice here, westerly anomalies, this per the 9th. So these are buoys on the ground getting actual measurements, not models of data a couple thousand feet off the ocean surface, hard data from the ground. Westerly anomalies, a little bit stronger than one would expect, still helping to support the development of Kelvin wave activity. Next up, subsurface temperature. And it's not the temperatures that matter so much, but this is depth. So surface, 300 feet down, West Pacific, East Pacific. It is the differences from normal that matter. And this, a pocket of much warmer than normal water, a Kelvin wave, is working its way to the east. It, the result of westerly anomalies and out-and-out westerly winds in January, February, and March, is now working its way off to the east. 4 degree, almost 5 degree anomalies in this Kelvin wave. Starting, here's the tip of it, erupting, and so that along the Peruvian coast, actually it's up along the Galapagos, but this is where the warm water that we saw along the Peruvian coast is coming from. This Kelvin wave is actually pushing east quicker than we expected it would. Still, we believe the peak of the Kelvin wave, this pocket here, will arrive on the Galapagos and start erupting up toward the surface in the early May to early June time frame. Another view of that data, this hypes it up a little bit more, suggesting 1, 2, 3, 4, 5, 6. You can almost see 7 there. 1, 2, 3, 4, 5, 6, 7. This suggests 6 degree anomalies. That would be very warm indeed. And notice the core of it is still not erupting along the coast yet. Hasn't even hit the coast, though it's pretty close to getting there. So we'll see what happens in the next several weeks. The next 3 weeks are going to be quite interesting. Once we get into late April, and early May, we should see water temperatures significantly rising along the Galapagos and the Peruvian coast. That would be great. That would set you up for what sort of looks like El Nino, but we need more Kelvin waves, more westerly winds to create to create more warm water, get the warm water pump moving so that there's almost a continuous string of warm water working its way off to the east. That would get you a real El Nino, because the typical El Ninos don't even peak out to December. Here we are in April, and we're just getting warmed up. Also, note, this Kelvin wave is very similar to another Kelvin wave that happened the exact same time last year. We thought a major El Nino was in play, and you saw what we got this winter. So we're not going to get too excited about this one, though there is much warming already in place. The atmosphere seems to be more primed. The ocean certainly is primed. We'll see what happens, but we are going to remain very cautious at this point in time. And yet, one more chart. This shows, so this would be the West Pacific here, the East Pacific here. This shows the migration of subsurface warm water working its way across the Pacific. This last April, this was the big Kelvin wave we talked about last year. Then there was a cool spurt, the upwelling Kelvin wave phase. Then 2 weak Kelvin waves in the fall time frame when you would expect strong Kelvin waves to be in play if El Nino was going to form. And then here we go again into the springtime, strong Kelvin wave working its way off to the east and building. This looks solid indeed, every bit as strong as last year's Kelvin wave. We'll see what happens and see whether there's more, whether we get into the core of the summer and get another one of these sort of weak Kelvin wave patterns going, or if something stronger develops. The thought is, the more you have warm water and Kelvin wave development, the more at some point it's going to make a connection with the atmosphere, and then you're finally going to trip over into a legit El Nino. But right now, we're in Modoki El Nino. Modoki El Ninos tend to go for 2, maybe 3 years before you finally trip over into a legit El Nino. So we'll see. Nothing is guaranteed. The pattern can be very fluky indeed, so it's more just watch and hope for the best. And finally, the forecast for the Nino 3.4 region. That is sea surface temperature anomalies forecast. Currently, we're sitting at about 0.9 degrees. Other data suggests otherwise. This 3.4 data suggests 0.75, so probably not too far off the mark. Anyway, by July, we're looking at supposedly 1.7 degrees above normal. By October, up to a roaring 2.4 and almost touching 2.5 degrees above normal by the December time frame. That would be a very strong El Nino if it were to occur, and looks like a nice tease, but we need to look at other data. So this is a combination or an accumulation of all the different models. Here you go, lots of them, El Nino type models. And the model that we just saw, the NCP CFS version 2, is right in here, in the sort of the top end of the range here. We see others that go even much higher. We see others that are lower. We see some that are suggesting weak La Nina conditions. And it's a mixture of dynamic and statistical models. So quite a spread here. The question is, how much do you believe any one of these models? How much do you believe any model that goes 6 months or more out into the future? Probably not a whole good idea to believe in any of them too much. But the good news here is the dynamic average suggests basically Modoki El Nino conditions continuing, as well as the statistic and the CPC consensus. They're both down in here. Everyone's generally averaging it out, saying warm conditions should continue. So all we're saying is view all this with a grain of salt. So for now, storm pushing across the date line. Looks like it's getting some traction. We'll know more in the next 24 hours, but it looks like some sort of long period swell, not particularly huge, will arrive along the U.S. West Coast and for Hawaii, providing some surf. The southern hemi, for the most part, is asleep. A little bit of energy, maybe for Hawaii, but very small is the key here. Longer term, El Nino, we continue to monitor it, look for good stuff from it, but we are not overly optimistic, especially after getting burned so bad this past winter. Also note that on our site, we've pretty much completed removal of Adobe Flash from all the weather and wave models. Now we're using JavaScript HTML5 approach, so all the weather and wave models should be viewable on your mobile devices, on your cell phones, on your iPads, and also on your computers, both Windows and Mac. There are a couple little anomalies. Some folks are reporting that the controls don't disappear, but for the most part, it seems to work pretty well. Have at it. It's better than using Flash because now you can look at your models, take them with you anywhere you go. So for now, looks like there's swell on the way. Enjoy it. Get some while you can before we get into the depths of summer. And we'll do this again next week. Same time, same channel. Thanks.